Welcome everyone in the second session of Python. This session will be learning about classes, objects, object-oriented programming, and more about Python. So let's get started with some slides. Python classes and objects first. So what are these classes and why do we need them? The short answer would be a class is like an object, constructor, or a blueprint for creating objects. So what are objects then? So classes and objects are terms used in object-oriented programming, where it is assumed that using a certain way of programming helps in maintaining the code for further development, and it is easy to add new features to your code. We will learn more about object-oriented programming later in this session, but first let's know about what are classes and what are objects. So classes in Python can be created with the keyword class, and then we can give them a name, whatever name we want that class to have. This is the way where we are defining a class. This is a place we will write all the details about this class. So for example, here we are creating car class. So all the details about this car and how to open it, how to buy it, what is the cost of it, and maybe a self-driving mode, the switch if there will be. So all these details will be inside this one class. So this defines a blueprint about this whole car. This is not the actual car, but it has all those informations about the real car. So as obviously if in the real Tesla car, they might have only one blueprint of the real car, but there are many cars, exact many cars of the same model might be available on the road right now. So all the models which are available on the road are the objects of the same class. So for the same model, the blueprint was created only once, but with seeing those blueprint, people created their own version of the car and the factory created that version of a car and sold it. So all the models which they sold are the objects, while the one stored in some research laboratory is that class or the blueprint of that car. So the same terminology in a code is class is that blueprint and the object is the instance of that class. So class we will define only once, but objects of the similar class can be theoretically infinite. Can have as many as objects from a particular only one class. And why do we need this class is because as with the example uh, with the car, the blueprint must have all the information about the car. So from price to how to drive it and all the details about the engine, if they are in the same place, it's easy for a person to see. And to if there's some fault, it's easy for another person to judge it and to see where the fault is. What if we had engine in some other if we had details about engine in some other factory and the details about the pricing in other factories and details about the self-driving in somewhere else, and then the person might not understand where exactly the problem is within the car if it gets broke down. So this is why we need everything in one space. This is why we create a class so that we can have all the details about the model of the thing which we want to create at one place. So it's better in the future. It's easy for us in future to work upon that. So after saying this, let's create a class in Python with some code. This is our text editor here. Now, as with the example, let's say class is a keyword, then we want car. Car will be the name of the class we are making. The colon, then automatically it gives us a space where we can write inside this class. Inside this class, we want the name to be Tesla. So this is where we have defined the class. Now maybe my car, and we make an object my car of type class, and then we added the parentheses to act upon this class. Now I can have this car is my car, and there can be other car of the same class, and there can be more models of the same type of car. So all of these cars, these objects are of same classes, and they are all the car class, and these are different objects. Now, as in the code, we have written name equals to Tesla. This name is called property of this object. So this is where we defined it once, but every object got this property. So to get or to extract this property, what we do is we add dot, then the name of that property. So let's try to print the name of my car model. We can say my car, which is which is the object, then dot name. Dot name, because name is a property variable. Let's save this and run our code. We got Tesla. As it is the name of the car, we can replace this with other model, or you can say other object. Let's run our code again. We got the same result, Tesla, because even their car is from the same model, or the object is made from the same class. That's why their properties are same. Let's know more about the classes in further slides. So as this was the name, this is the place where give the name for our class, and this is how we extract or access the property of an object. So this particular type of class is not actually useful in real programming. Let's see what are the real classes further in the slide. Yes, so this were the class keyword, the name of the class, and then to access the properties we use dot. So here, as you can see, there is some function we have defined which says underscore underscore in it, then underscore underscore, then we have self, comma name, comma age as an arguments inside this function. So this init function with a double score at the starting and the double underscore at the end is a constructor class. This init function is an Python inbuilt function with the construct, and this is a constructor function. What do I mean by a constructor function is that this function, whatever we write inside this function, will get executed when we create an object of this class. So when we create an object of this class, whenever is inside this function will actually get executed. So let's verify that with the help of some code here. So let's write class, and this class is a person name. Then within define, we can have this init function, and within this init, we can have self, comma name, comma age. These are the parameters, and let's try to print name here. Now let's create an object of the class we made. As we know, these are the parameters which we gave inside the constructor class. So it is one of the best place to give the values to a class which we might use somewhere later in the code. Like in the previous example, we gave uh, name as a name as a property for that class, and it was fixed to be Tesla. If we wanted, we can have given the property to be a variable which we can save inside a class using arguments inside this init function. So now, as these three are the variables, we must give them while defining this person. So we know the name can be given as name is equals to maybe where, then age is equals to 22. You might ask, what about this self parameter? We did not define or gave any value to this self parameter, although it's similar to self, the other two parameters, which are name and age. So let's just run this. Then we will talk about this self parameter. Let's run this code. We saw where printed here. This is because we are printing name inside this function. So this verifies that whenever an object is created, then this function is called, as it is the constructor function. Now let's talk about the self part here. So what this self does is it actually binds the arguments which we are giving as an inside the constructor of this class, and it binds those arguments and saves it for later use. And how we can do that is using self, then use a dot, and then we can give a variable name, maybe my name. And this is equals to the name parameter, the name argument inside the function. Similarly, we can save the age as my age equals to the age parameter. Now this self keyword which we used which we gave as a first parameter to this constructor function, then we used the self dot, then the variable name, and then we saved the value of whatever variable which we wanted. In this case, we are saving the name and the age inside the parameter called my name and my age. So why do we need to save it is the first question. So we need to save these arguments, the name and the age, because the idea of creating a class was to store the information all together in one place so that we can use them later on and we don't need to search in a different areas. So while making a person or while making an object of me, we gave this information, and then if we want to have another function which does like greeting the person, we can write that function inside this person class, and then we can use this name and age parameter. We don't have to give this detail every time, just we can give it once and we can use it all the time inside this class. And to use it, we need to save it, and we save it inside a self using self dot my name as a variable name. Let's see how we can do that. If we want to use these variables inside another function, let's say uh, greeting, then all we need to give as a parameter to this greeting function is self. Then save it. And within this function, if we want to print a greeting, let's say hello, then we want to print the name of that person. We can do like this. We don't have to give the name and the argument every time again and again. We can just give them and save them in a constructor, and we can use them whenever we want like this. Let's remove this part. Now let's see if we can access this my name property and my age property from our me object. As we saw in the earlier slide, that to access a property of an object, we need to use dot. We can say to me, this is the object. With dot, we are extracting or trying to access the property, and the property is my name. And similarly, the next line, we can have another property called my age. Let's try to run this code. Let's save this and run this code using Python 3 hello dot name of the file. And as you see, the name parameter which we gave to this person class, we can access them using the object me and using this dot notation, then the variable where we saved it using the self. So this is how we can actually save all the information all together in one place and access them using objects. Let's get further with our slides. So the init was the keyword for the constructor of the class. Then we know about the self and why do we need it. So as a recap, we can say self keyword was to join the attributes and the variables inside the class. And one thing to note is that this self is not a keyword in Python. It can be anything actually. It's just that it should be the first thing or the first uh, parameter inside the constructor class, and all the following all the following functions which we define inside the class. But usually self is the variable name which is used by most of the people. So it's just for a note, just remember that the self is not a keyword, it's just the most popularly used variable. Now we are saying that we in the last code, we defined this greeting function inside our class. So this greeting function, when it is defined inside a class, is then get binded to the object. So we can call this function from the object like the properties which we can extract, like the name, the my name and the my age. The way we extracted those properties from a class, we can do similarly for functions. And that's why these functions which we define inside the class are called methods. Let's write this again and see how we can access them. We have greeting, and the first thing which we give is self, and we don't need to give all the other details as my name and my age are saved with the self. Then let's print hello, then self dot my name. Now let's not print the my name and my age. Rather than let's call this method on the object me. Let's see how we can do that. We write me, the object name. Then to call a method, it's similar. We write a dot, then the name of the method. Here it is greeting, and as it is a function, so we need a parenthesis at the end. We don't need to give it any argument, although while defining we gave it a self as an argument inside this function. This self acts nothing, uh, but it's similar to uh, details which we are fetching from me. So we don't need to give anything inside this greeting function. Let's save this and run our code. We got hello where as we are running this function greeting by calling the object me method greeting. Similarly, if you want to give any uh, value or the parameter to this method, you can do this while adding a variable here, then giving that variable here like 1. We can give it 1. Although while defining we have two variables inside the greeting, but the self variable is taken from this object directly, and the next one, the x, that value will be equals to 1, which we are providing and keep passing it here. Let's try to print the value of x here to verify if it's getting 1 or not. Let's try to run our code and we saw 1 here. So this is correct. Every other variable or every other parameter which we pass inside a function, which is actually a method, we need to give those values, not the self value, as self is being extracted from the object itself. Let's get back to our slide for more details. Python dunders. Dunder method name is a common pronunciation for Python's built-in method name that starts and ends with a double underscore. So basically, all the inbuilt functions in Python, they start with a double underscore and ends with a double underscore. They are designed and given name like this so that we don't accidentally create an inbuilt function. So the double underscore key to say this whole phrase, it's quite difficult. That's why within the Python community, people prefer to say it as a dunder. And the init function, the built-in constructor class, uh, built-in constructor function for a class is an example of a dunder method. There are more dunder method, which are actually the Python inbuilt function. We can see them next in a slide. So let's see both of them working and know what are these two new dunder methods. Let's get back to our class, and here let's delete this greeting function, and instead of that let's write another dunder method which says repr. This repr stands for printable representation. What do you mean by representation? All the things which will return inside this dunder method representation will be printed when we directly print an object. So let's try to print something and return something inside this representation inbuilt dunder method. Let's return a string which says hello. Hello, after O we can add a space, hello, then self dot my name. So as we saw, we were doing similar thing with a greeting method, but we don't need to do that now. What we can is me is an object which we created of a person class. We can directly print it inside the print function, and let's see what we get. So as you can see, we got hello where as an output. This is because the present or the this inbuilt under method reaper or the representation function actually executes whenever we use this print function. Let's delete this and see what will happen to the object when we try to print it without a representation method. So it says some main.person object at some location. So because we have not defined any representation for this class, it's showing us a computer generated text of the location of this class in the memory. So this is use of representation dunder. Next, let's see what is this add and how we can use this add dunder. Let's define our add with double underscore at the starting and double underscore at the end. So this and is a predefined built-in dunder, which is actually an and add operator. Add operator, I mean the add sign. So between two objects, if we use this add sign, this is the place where we define what the Python should do. So as obviously while creating every method, we input the self, and because this will be working with other objects, we'll be adding to objects. So we need to give other parameter also as other or any other variable. Let's define what should return when we try to add to objects of person type. While returning, we can say it to be, it can be our name and we can have a space between us, and at the end we can have other. So now let's use this AND operator with our two objects. So let's try printing this. Let's try to save this value inside a string. So we can see we can use result string, and this is equal to me, which is a person type object, plus a string, which can be some text. We can say it text. So the plus operator right now is in between two different type of objects. One is a person type object and a text is a string type object. Let's see what this result string contains. Let's save it, run our code, delete this me printing part, and then see what our results are like. So we got where, then text. This is where we have used the plus operator, and this is the place where we defined what it should do when there is a plus operator with some other type of object. This is how basically this is another example of tender method and how we can use them inside of a class. Let's get back to our slide. Next, we can learn about iterators. As in the last session, we iterated over a list and a dictionary using a for loop. There's another way we can do that is using an iterator. Let's see this within a code. So let's first create a list which can be of elements A, B, C, and D. Now, if we want to create an iterator, we can name this variable as I. Then we use this iter function. Then inside this, we can give our list. Now, this I is an iterator as it's getting results from iter function. Now, to print each of the elements inside the list, we can do is we can print next, and inside this next, we can give our iterator variable, which is I here. Let's save this and run it inside our code. We got A here as it is the first element inside our list. Let's copy this code 4 times and let's see what our result will be now. So first we created an iterator and with the variable I it got saved, and this next function does is it's extract the first element from the list and then we print it, it is A. Then again using the next extract the next most element from the list, which is B, and then it prints it continues till D. So what if we add one more next statement right after this? Right now we have extracted all the till the D element, but there is no element after D, and still we are using the next non-iterator. Let's see what the result will be. So we got an error which says stop iteration. That is because the iteration was stopped because there is no element. So this next was giving error. This is what happens in background when we say for I in L and then we print I. Then run this, we get A, B, C, and D printed here. This is what happening in the background. The iterator and the iteration variable I gets the value and it stops automatically. We don't see that in background. Let's get back to the slide. So we studied about this iteration and how we can iterate over a list using iter and the next, because there are two more tenders in a Python which can be used to create a custom range. Let's create our custom range and with the help of class, and let's define our iter and next inside this class. Let's delete this, and here we can say class, then we can say my range. Inside this my range, we want to only get the even numbers. So let's first create init, then we give the self parameter, then the starting point and the end point. The starting and end are the position of the starting and ending places where our range should work. So let's create and save these variables inside the self using self dot num for the start and self dot end for our ending parameter. Next, we can define iter. This is where we define our iterator, as every method in the class must have the first parameter to be of self. We give it the self, then in the return Right now, we only return the self. Next is all the things which we want logically to work should be defined inside the next tender method. Again, we give only self as a parameter inside this tender. Now, what we want is we only want the numbers to be printed in even orders. So we can say that we can use this self.num variable. We can have the value of this variable to be twice every time uh, after it gets created. So we can have this 2 plus self.num so that we can have this value to be 2 times added after every iteration. Now let's print return.self number. What it will does is in whenever now we'll have this range in every iteration. This is the number which will be saved inside an iteratable. So we have created an iterator, but we have not defined when should we stop. This way our for loop will keep on going forever. So to do that, we must have an if statement which says if self.current number is greater than self.end, we must raise stop iteration. You don't need to worry about if you don't understand what is this part we are doing here. You just need to know that we are stopping the iteration whenever the self number variable reaches more than the self end value. This is this myRange class is how we create an iterator. Now use this to create a range. Let's say my range that goes from 1 to 10. Let's print our x and see what the result will be. So we got 3, 5, 7, 9. As the starting, the number value was 1. Then we added 2 here. So we got only the numbers with the gap of 2. So if we give this as 0, it will give us the even numbers which we wanted. So this is how you create an iterator in Python using next and iter dunder like this. Python object-oriented programming, or in short, OOPS. Object-oriented programming is a way of programming big things so that the resultant is the most optimized code. What I mean is that this is a way a program should be written. By program, I mean the big application. You may think of something like the whole Windows app, the whole Windows OS. These, when the project grew and when there are a lot of features and a lot of things inside a program, then it's quite hard to maintain the usability inside the code. To have the most optimized way to debug the code or to write a new part inside a code or to update a code, this is a structure. There are some theories which you should follow inside your code to have it to be of most optimized way of editing and using it. So there are some theories in object-oriented programming which tells us how you should code and what are the things which are needed inside your code structures to make it the most efficient. So the object-oriented programming first, as the name suggests, it wants objects to be created, and to make an object we need a classes. So everything will fall inside the classes only. That's why we studied about the object and classes. Now let's talk about the other pillars of object-oriented programming one by one. Inheritance in object-oriented programming. Inheritance allows us to define a class that inherits all the methods and properties from another class. Like there is a parent class which has all these parameters and all these methods which are already made inside the parent class. Now we want a child class to inherit all these uh, details, all these parameters and method from the parent class. And we should be able to do that inside of Python. And this property of doing that is called inheritance. So let's see how we can make two classes and inherit uh, from the parent class, inherit something into a child class. Let's see with some examples. So here in this picture, as you can see, we have two classes made. But while defining the person class on the top, we don't have any parentheses. While in the second class, student, we have in the parentheses the person, the person class. This is how we define that the student is derived from a person class. As every student is a person, but every person is not student. So person is a parent class and student is a derived class. Let's write this code and understand while writing what are each of these components and how is this code exactly parent and child classes, and how is the inheritance property actually working. Let's create our person class, and within init we can give self name age, self dot name we can give it as name, and then the self dot age we can give it as age. Now define the greeting. Once again we give the self as a first parameter and we print welcome, then the name of that person. We have defined this person class. We can test it using person, and we can give name as person name and the age as 22. Now let's access this greeting method from me object. We can do that using me dot greeting, and don't forget to add the parentheses as it is a function. Let's run this, and we got welcome person name, and we are printing, although we are printing inside our greeting function. So let's remove this printing part which is redundant here. Let's run our code. We got welcome person name. So this is how a normal method works. Now let's try to create a children class for this person parent class. As we studied, we can have a student, and inside while defining the student class, we give person and specifying that person is a parent. So inherit all the method and properties from this person. And we can say pass. Pass means nothing, just pass this line. And we need to have one line to create a class. So we are doing nothing. We don't even have a constructor class or init class inside the student here. We just pass these properties. Let's replace this me object to student. Sorry, let's leave it as it is. And now this me is same, and but we can replace this person to student. Although we have not defined any in it, that's why we don't have any place to give any parameters inside the student class. But we will go ahead and let's see what our result will be. So the results are exactly same. We are printing welcome person name again. This is because although we have defined all the details inside the student class, but the student class was inherited from person, and all these details were actually also being executed inside this person class here. So this is how we use an inheritance. Let's know more about the inheritance in the slides. So right now what we studied was just using another class and specifying a parent for that particular class. And by default, Python inherits all the details from its parent's class. Now, what if we want to add some more features or add or use some of the details from its parent class? How we can do that? Let's see that inside a code. So if we use a constructor class here, which is init, and again have a self, and then if we want to add the last name of a person, and we can have it here, and then in the last name we can give last name. Sorry. So self.last name is now equals to last name parameter inside this function. Let's try to give this last name after all the details which we gave. Save this. As you can see, there is student with red underlined. This is because let's run this and we'll get the error. It says got an unexpected argument name. What is happening is that when we define the init inside our student class, now we have two constructor class, one of person and one of student. And when we define the student constructor class runs, while the person constructor class did not get a chance to run. That's why we got the name, we got an error that name is not a parameter, because the parent class constructor never got a chance to run. Let's see further in slide how we can resolve this issue. So let's open our text editor again. In Python, first thing which we need to know is this super keyword. This super is a function which actually calls the parent class here, then we want to call the init function or the constructor for a parent class. So we'll use the init method here. Now, as the person class takes two parameters, which are name and age, so we must give these parameters here. Now we are inside the init function of a student class. We must have the name and the age in the parameters of student also, so that we can pass it to the person class. Let's add them here, name, age. Now, whilst defining a student, you will have this name and the age parameter, and this name and the age parameter will then be passed to the super function, which will call our parent class. So this is the place where our parent class will be called, and its init function will be called using these arguments which it wants. And then we saved our self.lastName in lastName variable with the self. Now let's try to run our code again with the student only and passing all these variables. Remember, we are using the greeting method, which is defined in person only. Let's save this, run our code. We got welcome person name. So after we initialized our parent class constructor, all of the features we can use, and we can even add more features or more properties inside our student like this. So this is the true inheritance. We can inherit any property from our parents, and we can even add more properties from ourselves. So this is inheritance in Python. Let's see more uh, in the next slide. Encapsulation. Encapsulation describes the idea of wrapping data and the method that works on data within one unit. This put restriction on accessing variables and methods directly and can prevent the accidental modification of data. What this means is that, like earlier in inheritance, we were able to use any property and any method of the parent class. But what if we want to hide some detail inside the parent class? What if some parameters we don't want our object to access from the outside? Now the encapsulation principle or the encapsulation theory comes into play. We need to define the variables in three ways. We must be able to define the variable in these three ways. One is a public member, second is a protected members, the third is private members. These public, protected, and private members can have properties and methods. So as the name suggests, public members will have all the properties and methods which are publicly available to the object. Protected members are the members which are protected from using formed from the object, while the private members are the members which are prohibited and which you cannot use even in the derived class or from outside of the object. Let's know more about encapsulation in the next slide. So here is the code for explaining encapsulation. Let's use our text editor and see what do we mean by encapsulation. So first thing to know is that to make a member or a property or a method, protected or a public, and how can we make it private? So by default, all these members, which are properties and methods, by default, they all are public. So as we saw, we can access this greeting method from the object from outside because this is a public, this comes into a public member. Next is if we want to protect some member which we don't want them to access from outside, is that we use a single underscore while defining their name. So now this member or this property age is now protected, although you can access it from the outside, but it is not advised to use underscore to access the members from outside. So we can say that this property uh, is being protected. Let's try to print it. We can say me. Usually how we access the property is directly assigning their name, but as there's an underscore in a name, that's why we will say it is being protected. But although it is only protected, it's not private, that's why we will be able to print it. We got the number 22. But as you can see, if someone will see that there's an underscore, uh, they can directly see in the code that someone is using a protected member, and which is not advised. So this will help them to debug some error. Let's get back to our slides to know more. Now we have a private member. How to define a private member, and how can we see that the private members are not being accessed from outside? Let's see that in the code. Similarly, right now we make this age variable as protected. Now let's try to make it private by using one more underscore. So all the methods which you want all the methods or the properties which you want to be private, that you don't want people to access from an object, you can use this double underscore. Now let's try to access our double underscore, then this age parameter. Let's see what will happen. It gives us attribute error. The student object has no attribute double underscore age. Although we know we have this double underscore age parameter. This is how we can actually protect or actually we can create a private uh, private methods or properties. Similarly, we can do that for greeting. We add a double underscore. Now we cannot access this greeting method from outside. Let's try this. We got an error because this double underscore made this a private method, and we cannot access the private method from outside like this. Let's get back to our slide to see more. Next, we have polymorphism theory. What is polymorphism? The word polymorphism means having many forms. In programming, polymorphism means same function name but different result. For example, let's say when you want to add some numbers, then let's say you want to make a function which can add n numbers, and this number is not defined. You can have 3 numbers or 4 numbers or 5 numbers. How can you do that? The number of inputs are not defined. Similarly, if we want to get the length of a string or a list or a dictionary, we use a length function. Although to calculate the length of a string and a list and a dictionary are a different task, but the name of the function remains same. This is the base concept of polymorphism. The name is the same, but the functionality differs when we use it on different objects. Let's try to see this in code and we will understand more there. Let's open our text editor. Let's clean this. Let's have a student class where we have defined its name and let's give this as self.name is in the name. Then let's define a greeting. Let's call it greet. Then within the self, let's print hello, then the name of that student. Let's create another class which can be a teacher. Let's define in it with the same self and name. Self.name is equals to name again, and let's define our greeting function for teacher class. We can have the same name. Now the greeting for teachers will be different and the teaching and the greeting for student will be different. For teacher, it may be good morning or good evening. Good morning, then the name of the teacher. Now let's create two objects, one of student class and one of teacher class. Let's say me is a student of student class with the name, my name, and the sir is an object of teacher class with the name sir. Now let's print their greeting with the help of the object me.greet, and for sir the same function greet. Let's try to run this code and we see the hello, my name, and then the good morning, sir is being printed as this is the greeting for the student and the good morning, sir is the greeting for the teacher. So the name of the function is same while the functionalities are different for both of them. The best way to perform this code will be to keep both of them inside a list and use a for loop. Then we will call this greet function only once. So let's say for people in list me and sir, for every people call greet function. Let's save this and run our code. And we again say greeting for both of them are being printed here. So right now, this is the best case to explain polymorphism. We had the same function dot greet method, and on this particular method, we had two different outputs, and those output depended upon the different type of object it was operating on. So this is how you create polymorphism or the polymorphic functions inside Python. Let's get back to our slide. Now let's create a polymorphic function with some inheritance. This is one of the most famous example you will see within a polymorphism, and it is asked in many frequent examinations. Let's see this inside of a code. So the idea is that for square and for rectangle to calculate an area, the formulas are different. For square, you just need one side. For rectangle, you need both sides. But in code, we want to call only one function. We want to make only one function, the area, to calculate the area of square and to calculate the area of rectangle. This is the best use case for polymorphism. So let's create that. So let's create our square class and let's create our init, and while defining a square, we just need a side of it, and the side is sufficient to calculate the area of a square. We can save this parameter side in self.side equals to side. Next, create a method to calculate an area. We'll give it a self parameter, then return self.side into self.side. This will give us the area of a square. Let's create a class for rectangle. And as every rectangle, uh, as rectangle can also be a square. So let's have the square as a base class for this rectangle. In the init, let's define the self, the length, and the breadth for this rectangle. And then let's call then initialize our square class using super. And to initialize its constructor, we use init. Then we can say the side is actually just the length. Then we can save the breadth as self.b. Now we can overwrite this area method in the rectangle, although this area is being defined inside the square only, and every rectangle object will also have this method accessible. But we will override this area method for rectangle classes. Let's create our area method, and inside it, let's return self.length into self.breadth. Self.length was defined inside the square. So this length is actually the side. So self.side into self.breadth, as this length was going inside the slide parameter, and then the slide parameter was being saved as self.side. And the self.b is actually the breadth parameter, the value of the breadth of rectangle. Let's create our two objects, one square and one rectangle, and try to print their areas. While creating a square, we just need to give one value, which is its side. While creating a rectangle, we must give both values, length and a breadth. Now, again, let's print their areas. Now, let's save this file and run it. We got 25 and 50, as 25 will be the area of square of side 5 and the area of rectangle of side 5 and 10 will be 50. So this is one of the best use case of polymorphism using inheritance, and we actually shorten our code. We did not need to define the another parameter here, and you can imagine when your project grew and there will be many more things which you don't actually want to define again and again. You can use this polymorphism and the inheritance like this. And in this short example, you can see it actually saves some lines of code. Let's save it and get back to our slide. So this was polymorphism in object-oriented programming. Let's see more things which are important in Python. These are not structured as some kind of things, but this will help you to write your code and will help you to understand the Python code easily. Let's see one of them. Scopes in Python. What is a scope? Scope is an area or the positions where a variable can be seen. So when we define a variable inside a function, what are the places where we can actually see this function? Sorry, the variable. So what are the places where the variable will still be defined? Obviously, if we define this variable inside a function, we can have this function anywhere inside the function. But even after calling the function, all the variables which are defined inside the function uh, are erased and we cannot access them outside from a function. And the other scope is a global scope, where the function is defined at the same place where the variable was defined. Now that variable can be seen from inside the function, but the variable value cannot be changed from inside the function. The value will retain its status in the global scope, and it will replace and it will change its value in a local space or a local scope. Let's see this in code to get a better understanding of what is a scopes. So let's see, we define a function called fun and we don't have any parameter for it. We have a name variable whose name is local. And now we print this name. Now we call this function and here we try to print this name variable. Let's print, let's call our file, and here we got name error. The name and quoted name is not defined because the name is not defined in this space or in this scope where the function is made and where we are printing the name. The name was defined inside the function scope. Now let's give this variable name equals to Let's remove this. Now let's give this name as a local value and then include this name in parameter and then see what it does. Can we access this name from outside a function or not? Again, we first see the local printed because this function was running. Then we tried to get the value of the name, but the name was not defined in the scope. Name was only defined inside the function scope. Let's try to change this way by defining the name in a global space or the global scope. And then we don't take this parameter as an input. We first print the name, then we change this name to local, then we print this name again. And we don't have to give any parameters to the function now. And at the end, let's try to run our code. We got a local variable name undefined because this name was not defined inside a function. That's why this global scope was different from the scope inside this function. Let's remove this. And now we have a name variable inside the function and one name variable outside the function. Let's try to run our code. And we first see the local get printed and then the next line the global is printed. This is because here the name uh, which is a variable name is actually having a value of local and whose scope is only just within this function. While here printing the name, we don't have this parameter available now. We are in the global scope, so this name parameter value will get printed, and that's why we got global at the end. Now let's see if we want to use the variables defined inside the global space, what can we do? So there's a keyword in Python named global. We can use that as we have this keyword global, then we can add the names of the variables which we want to use inside the function and don't have to import it or don't have to give it in the parameters while defining the function. So the name, we say the global, then the name. So this name variable now changes its scope from global to the local. Now let's print the name and again change the value inside this variable to local. Let's run our code. We see first our value was global, then the value got converted into local while final printing. This is because this is the same variable whose scope we changed from global to local here, and while going back to global, it retained its value as it was defined in a global space or a global scope, and that's why at the final, if we print the name, the value which we got was local. This is the use case of global keyword in Python. Using that, we can change the scope of variables and actually change the variable inside the code. Python modules. If you have a function defined in one file, and that is quite a big file, and you have another file where you want to use that function, but you don't want to rewrite the whole function as it's already being written in that file. This is where the modules comes. A module is nothing but a way to import something or some function or some value from another Python file. So let's see this with an example. Let's close this, and here let's create another file, and let's save this file as app.py file. And within this app file, let's write a simple function. Let's say define, and within this function, we can say print this is an app file. Now this function is in the same place where our hello.py file is. And there's a function written inside this app file. We want to use that function in our hello.py file. So what we do is we import that function from app file, and to import it, we say from app. Remember, we don't give the full name of that file. The .py extension, we don't need to add it here. From app, which is the file app.py file, we say import, then the name of that function, which is fun. Again, we don't give the parentheses, we just need to give the name of that function. Now let's call this function. As you can see, we have not defined this function here. We are importing this function from the app file. Let's run our code, and we can see it prints this is an app file. So we are importing the function written in one file and executing and calling them in another file. This is how you can do that. Let's get back to slides. So this function was in file 1 while the application or while the function was being called in a file 2. Similarly, right now what we did was we had the files in the same folder. What if we have these files in different folder structures? Imagine there's a project folder, and inside it there's a main.py file, and your app.py file is inside the folder 1. Then inside that folder 1 there's a folder 2, and inside that folder 2 there's a app.py file. Now you cannot directly say from app import function. This is where we need a relative import. So to include such files, we first thing we need to do is we need to have our under init.py file to be located in the project folder and in all the folders where we want to access the files. What it does, it makes the whole folder as a package. So Python can access each of the folder and can uh, access all the files, Python files within the folder structure. Let's see with an example here. In our code editor, let's close this file. So let's delete this app.py file we just made. So we are in our project folder. Inside this project folder, we have a folder 1. And inside this folder 1, we have init.py file and a folder 2. Inside this folder 2, again, we have init.py file and an app.py file. Let's open app.py file. As you can see, this app.py file has this function is from app.py file. And we can say one more thing. this file is inside folder 1 and folder 2. Let's save this. While here, this is the hello.py file, which is indirectly the project folder. Now we need to relative import this app.py file and then import the function. Let's delete this. So here we can say from, for relative importing, we use a dot, then we say folder as it is first inside the folder 1, then again dot, then we say folder 2 as it's inside the folder 2, then we say the name of that file, which is app, not, we don't include the last .py, remember that. Then from this relative location, import fun, which is the name of that function. Let's save this and run our code. This dot must not be here. Sorry for that. So let's save our file and run it again. You can see this function is from app file, and in the next line we got this file is inside folder 1 and folder 2. So this is how you do the relative importing in Python. Let's get back to our slides and know more of these features. Next, we have the built-in math library of Python. You can use this library to do a lot of commonly used math functions like minimum of the numbers, maximum of the numbers, or the absolute value for any number, or you can use a power function which gives you the power of any number with any other number. To use this library, you must import math at the starting of this uh, code, and to use the uh, functions inside this math library, you can use dot like we use to get the method from an object, treat this math as an object, then use the dot and then the name of the methods we want to call, like the square root. We can do that using math.sqrt. This will give us the square root of the number which we give inside this function. Similarly, there's a ceil and there's a floor functions inside this math library. You can try them out and look for different functions and methods inside this math library, and this might come helpful in further math projects. So this is how you import the math library. Finally, what is a package and what is pip in Python? Pip is nothing but a Python installation package manager. So there are a lot of libraries available in Python. We know that, that's why we are learning about Python, because it's wide availability of the libraries written by the Python community. So to use those already written codes or the libraries, we use pip to install those libraries. You can use pip install, then the name of the library which you want to install. You can run this in the terminal. Let me show you how you can do that. This is our terminal. Here, if you write pip install, then the name of the library like numpy, then hit enter, it will start installing. In just one line, you can install the widely available libraries or the internet of the Python. and use them in your project instantaneously.